A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Our module is about how to create a shear force and bending moment diagrams of beam. Let's see how to create this. I have taken a reference problem from Mechanics of Material book by Beer and Johnson. For a timber beam and loading shown in figure, draw shear force and bending moment diagrams and determine the maximum normal stress due to bending. The cross-section properties of the beam shows that the height of the beam is 250 mm and the thickness of the beam is 80 mm. Make sure that during the extrusion length 2.5 meter, 3 meter and 2 meter, we have to uncheck the merge result. This we have to done because during simulation we need a joints for the application of external load. Select front plane and create sketch. Select center rectangle, smart dimensions, height is 250 mm and thickness is 80 mm. Go to features and select extruded boss base and select extrusion length is 2.5 meter. Select this face and create a new sketch, convert entities and go to features, extruded boss base, and this extrusion length is 3 meter. Make sure uncheck the merge result. Select this face, create sketch, convert entities, go to features, extruded boss base, and this extrusion length is 200 mm, and make sure to check unmerge result. Go to Solidworks add-in and select a simulation tab. The simulation pop-up appears on the top. Select simulation, new study, static. Okay. First of all, select all three bodies, right click and treat selected bodies as beam. Apply material. Our material is wood, timber beam. Go to wood and select this one. Now apply the external load. Now apply the fixtures. Fixtures are basically constraint that allows the body to move in either one direction or completely fixed, mean that there is no translation in other direction. Here we have a pin joint. In case of pin, the body is not going to translate in any direction, so we use immovable fixture with no translation. Select this joint and go to symbol settings. These three arrows shows that the beam is not going to translate in X, Y or Z direction. And at point D we have a roller. Roller joint mean that the beam is going to translate in one direction but restrict translation from other two directions. We have to allow the translation in z direction but restrict translation in x and y direction. Go to fixtures, fixed geometry, and use reference geometry. Select this joint, choose reference plane, right plane as a reference plane, the arrow shows that the beam is freely to translate in z direction but restrict translation in x and y direction. Now apply the external load force. At point A we have a load of 20 kN. Select joint, this joint, and select this edge as a reference edge and apply a force of 20,000 Newton. Reverse direction. At point C we have a load of 40 kN. Select joint, select this edge as a reference edge and apply a force of 40,000 Newton. Run this study. Select stress plot, edit definition, stress into megapascal, deformation scale true, chart options show maximum and minimum annotation, and floating. As from theoretical calculation shows that the maximum bending stress produced in the material is 60 megapascal, and as we've seen that from here the maximum bending stress is 60 megapascal, and it is where we have a pin joint. From shear force plot we have a maximum force of 26 kilonewton and minimum force of minus 20 kilonewton. Let's see results. Define beam equations. Shear force, chart options show maximum and minimum annotations, and this one floating. Okay, As seen from the shear force diagram that the maximum shear force is 26 kN and minimum is minus 20 kN. From literature, we also have that the maximum shear force is 26 kN and minimum is minus 20 kN. Similarly, for bending moment diagrams, select define beam diagrams. Bending moment diagram unit is Newton meter. Chart options show maximum and minimum annotations, and from here select floating. As seen that the maximum bending moment is minus 50 kilonewton meter and the minimum is 28 kilonewton meter.